Hi. Today the main topic is the B tree. B tree is just the data structure of the computer science. But I'm not gonna like repeat the same stuff. What does the other YouTuber doing this? Actually, you have to know that the data structure is not just theory. It's just being used in widely in the real time. For example, like some kind of database or Redis, Redis or the cache in memory database, um, and B-tree is widely using it. But the sad thing is that a lot of people in the college they don't teach how to utilize B-tree. They don't know. They don't teach us why we need such a B-tree and what's the context of B-tree is being made. So today I'm just gonna talk about those kind of stuff. But before begin, you have to understand something. Um, example, there are a lot of data. Example, you wanna store the some kind of your employee data, and to get this kind of file organization of employees, there's a two two types of or two command to do it, sequential or random. Example, the sequential means that, let me give you an example. The from our employee file prepare a list of all employees names and address and whatever stuff. But random is, okay, from our employees file extract information about employee J Smith. So sequential is, there's an employee and there's a file of the bunch of employees, right? And prepare or the list of it. Example, you have 1,000 or 10,000 employees. Just prepare all of it, and just find the employee that matches the some kind of the featured value, and just get it. So that's sequential. But random is from our employee extract only for the employee that J Smith. So we're just gonna do the algorithm stuff. And but the question is, you have like really like a lot of employees data. Example, employee. So there's the employee data, and there's any employee gonna have some kind of ID. His ID of it, the unique ID. Uh, I mean, of course, I mean, like if you get a job, you should have an idea of your job, right? You should have like unique ID or unique number of your job, of your title, and that's gonna be ID. Or example, name is gonna be your part of your this kind of data, and also the age or whatever stuff is gonna be here. So the one employee is gonna be have this kind of metadata, but what if there's a 10,000 of it? And you should think about like how to manage like over 10,000 over like 10 millions of it. The, if there's a lot of data, we should try to optimize it, because to waiting for this read and data, write for data, it requires so much of time. So we just, rather than we just read it from the top to bottom to top, we just figure out what's the best way. And that is why data structures come from. It's just the nowadays, all of the new modern the data structure or the just like whatever software, it's just the like this just the bunch of abstraction of like of the early days. Example, we store data to the variable, but in assembly language, when we just compare just made and there should be only one language which is assembly. Assembly, there's no some kind of variable thing. They put they put their data in the register, the rear storage of the CPU. But somehow they abstract those kind of thing, and they make a OS, and they make OS, they make some kind of virtual memory, those kind of stuff, and we just now finally can store data to the variable rather than putting on the register of it. So those kind of abstraction is kind of valid into in the comparison in the data structure. Okay, so and I think the more important part of this kind of stuff is the record. What is record? So record is just the unit of data. Actually, this is record, and the K is alright. I'm just gonna try to give you the formula. Let's say Ki and AA. It's just a record, and the K equals the key. So our key is gonna be ID because that has to be unique, right? And also associated info is like this part. So now we just know what is record thing, but how do we really store this kind of stuff? Example, you wanna find the employee, you should know the ID of it. You should, for example, if the employee's name is Merlin, and his age is 22. So you should filter it out, and you should also get the idea of it, right? But the idea of this kind of, you should also store this kind of ID stuff, because I mean, every employee will have this kind of key value, and you should just store in the one just file, whatever file, and that's called index. Index is just what I know about index is just the set of the OR keys. So one index, example, there's an index, gonna reference the one record, and next the other record, and third record. And of course, these gonna be the one record, two record, three record is gonna be independent, because I mean, like, employee one, employee two, employee three, they are different person, right? But those kind of stuff, the file size is really big. So we don't put really main memory RAM here, because the storage is really small. And also the reason why it kind of small of it is not really like, example, if it's like a lot of data, some of it, your RAM is gonna be hard to upset, because our operating system, the operating system is gonna be managed the memory, the RAM. So you're just gonna do the whatever stuff, like if the process is making, it goes to RAM. So RAM is kind of really, there's already a lot of stuff here. So we put the disk on here, or hard disk, or this kind of hardware. So this is why kind of like server engineers are really required. So server engineers are really hard, because I mean, like, to become a server engineer is kind of hard, because you have to know about those kind of stuff. What if because like there's cost issue about maintaining index, but what if there's like some kind of like the record that don't require some kind of bunch of index? So you should like figure out what's the best database for your data, example MongoDB or those kind of stuff. So I think that's why server engineers is kind of really it requires a lot of like CS, computer science skills, but whatever. So, and furthermore, the random access devices, example, like random access devices is like those kind of like what we just described about, and it requires a fixed amount of data per read operation. The reason why it requires a fixed operation, the size of fixed operation, is because actually the disk is really it's really kind of like fixed amount of it. In the disk, the first sector is a master boot record, and the size of it is the 520 byte. So example, like bootloader, we store the bootloader in the first sector of the disk, and there's kind of 500 bytes. So everything is like everything is fixed. So we just use as the fixed amount of data per read operation. So now those kind of issue made us to think what is the best optimized data structure for it? Rather than putting into one array, we just think of three things. Because what if, example, there's just kind of data, the root data, and there's gonna be your key, example one, 12, and those kind of thing, whatever stuff. And the tree is kind of good is because it represents hierarchy. Even example, when trying to compare the program language, the variable, those kind of stuff, split into tokens, and it makes into tree to prove to show the hierarchy of it. So if you look at our data nowadays, all of things almost hierarchy. There's a bunch of hierarchy. Example, there's a metadata of me, but there's more of the metadata of me that use some kind of thing. I already signed up, so there's gonna be my email address and my name of it. But if I put some kind of um, example, I make like I'm sorry I purchased a new I purchased new clothes for it. So based on this data, the purchase data is gonna come from. So that's gonna be hierarchy. So that is why the tree data structure is kind of really really good for this kind of stuff. But the bad thing about the normal tree is binary tree is the binary tree is like there's a root of here. You if the data is small, you put here. If data is big, you put right here. So it's just the example like 5. If data is small, put here. If data is bigger, put here. And there's this or something like those kind of thing. And those kind of binary tree is kind of good, but there's kind of limitation of it. But what if there's numerous the depth on it? Because our best way is make at least 2 of it. And that's gonna be really great because we don't have to go deeply because we just have to define the next neighbors on it. But if it is already deep, it requires more time complexity. So that is why we chose there's gonna B tree. So B tree, if there's node of here, node of B tree, you put the rather than just one node, you put the 2 nodes, 3 node, or 4 node to make a fixed depth on it. So that is why the B tree is kind of efficient for because the if you trying to find some kind of data in the some kind of tree data structure, it all recursive, and when the depth or height of the tree is increases, the time complex or the finding amount of time is going to be increased. So that is why we choose the B tree. So that is kind of like introduction of why we need B tree because that's kind of like a limitation of a normal or binary tree. And so this is it. So like next video, I'm just gonna talk about more about like B tree or how does it work. So this is it. Have a nice day. See you next time. Bye bye.